Hi friends, welcome. This is the part 1 of our mechanical engineering competitive exams theoretical questions and answer series on strength of materials. So friends, let's begin. Friends, this is question number 1. Whenever some external system of forces acts on a body, it undergoes some deformation. As the body undergoes some deformation, it sets up some resistance to the deformation. This resistance per unit area to deformation is called. Here options are strain, stress, pressure or modulus of elasticity. So here friends, correct answer is option B, that is stress. Next is the unit of stress in SI units is, here options are Newton per mm square, kilonewton per mm square or Newton per meter square or any one of these. So here friends, correct answer is option D, that is any one of these. Next is the deformation per unit length is called, here options are tensile stress, compressive stress, shear stress or strain. So here friends, option D is the correct answer, that is it is called strain. Next is question 4. Here the unit of strain is, here options are Newton mm, Newton per mm or no unit. So here friends, correct answer is option D, that is no unit. Friends, question 5 is strain is equal to, here friends, these are the options and where L is equal to original length and delta L is change in length. So here friends, correct answer is option B, that is strain is equal to delta L upon L. Next is question number 6. Here, when a body is subjected to two equal and opposite pushes, as a result of which the body tends to reduce its length, the stress and strain induced is compressive. Here friends, options are true or false. So here option is the correct answer, that is it is true. Next is question 7. When a body is subjected to two equal and opposite pulls, as a result of which the body tends to extend its length, the stress and strain induced is. Here friends, these are the options and here correct answer is option C, that is tensile stress, tensile strain. When a body is subjected to equal and opposite forces acting tangentially across the resisting section, as a result of which the body tends to shear off across the section, the stress and strain induced is. Here friends, these are the options and here correct answer is option D, that is shear stress, shear strain. Okay, now next is which of the following is a proper sequence. Here friends, sequence are proportional limit, elastic limit, yielding failure. Next is elastic limit, proportional limit, yielding failure. Option C is yielding, proportional limit, elastic limit, failure and none of the above. So here friends, correct answer is option D, that is none of the above. Here now next is Hooke's law holds good up to. Here friends, options are yielding point, elastic point, plastic limit, breaking point. So here friends, correct answer is option B, that is up to elastic limit. Hooke's law holds good up to elastic limit. Okay, next is whenever a material is loaded with whenever a material is loaded within elastic limit, stress is dash strain. Here friends, options are equal to, directly proportional to, inversely proportional to. So here friends, correct answer is option B, that is stress is directly proportional to strain. Okay, now next is question 12. Here the ratio of linear stress to the linear strain is called. Here friends, these are the options and here correct answer is option B, that is modulus of elasticity. Next is the unit of modulus of elasticity is the same as those of. Here friends, these are the options and here correct answer is option D, that is stress, pressure and modulus of rigidity. Next is when a change in length takes place, the strain is known as. Here friends, these are the options and here correct answer is option A, that is when a change in length takes place, the strain is known as linear strain. Next is question 15. The change in length due to a tensile or compressive force acting on a body is given by, here friends these are the options, and here P is equal to tensile or compressive force acting on the body, L is the original length of the body, A is the cross sectional area of the body, and E is the Young's modulus of the for the material of the body. So here friends correct answer is option B, that is PL upon AE. Next is the modulus of elasticity for mild steel is approximately equal to, here friends options are 10 kilonewton per mm square, 80, 100 and 210 kilonewton per mm square. So here friends correct answer is option D, that is 210 kilonewton per mm square. Okay, now next is question 17. Here Young's modulus may be defined as the ratio of, here friends these are the options, and here correct answer is option C, that is linear stress to linear strain. Young's modulus is linear stress to linear strain. Modulus of rigidity may be defined as the ratio of, here friends these are the options, and here correct answer is shear stress to shear strain. The unit of Young's modulus is same as that of stress. Options are true or false. So here option A is the correct answer, that is it is true. Next is two bars of different materials and same size are subjected to the same tensile force. If the bars have unit elongation in the ratio of 2:5, then the ratio of modulus of elasticity of the two materials will be, here friends these are the options, and here correct answer is option B, that is 5:2. Okay, now next is question 21. When a bar of length L and diameter D is rigidly fixed at the upper end and hanging freely, then the total elongation produced in the bar due to its own weight is, here friends these are the options, and here W is equal to, small w is equal to weight per unit volume of the bar. So here friends correct answer is option B, that is WL square upon 2E. Next is the deformation of a bar under its own weight is dash the deformation if the same body is subjected to a direct load equal to weight of the body. Options are equal to, half, double or quadruple. So here friends correct answer is option B, that is half. The elongation of a conical bar under its own weight is dash that of prismatic bar of the same length. Here friends these are the options, and here correct answer is C, that is 1/3. The elongation of a conical bar under its own weight is 1/3 that of prismatic bar of the same length. Here friends next question is question number 24. The length of a conical bar is L, diameter of base is D, and weight per unit volume is small w. It is fixed at its upper end and hanging freely. The elongation of the bar under the action of its own weight will be, here friends these are the options, and here correct answer is option C, that is small w L square upon 6E. Next is strain rotators are used to, here options are measure shear strain, measure linear strain, measure volumetric strain, relieve strain. Here friends correct answer is option B, that is measure linear strain. Okay, strain rotators are used to measure linear strain. Next is question 26. A bar of length L meters extends by small l mm under a tensile force of P. The strain produced in the bar is, here friends these are the options, and here correct answer is option D, that is 0.001 L upon L, L upon capital L. The extension of a circular bar tapering uniformly from diameter D1 at one end to diameter D2 at other end and subjected to an axial pull of P is given by, here friends these are the options, and here correct answer is option C, that is delta L is equal to 4PL upon pi E D1 D2. Next is the extension of a circular bar tapering uniformly from diameter d1 at one end to diameter d2 at the other end and subjected to an axial pull of P is dash the extension of a circular bar of diameter under root of d1 d2 subjected to the same load P. Options are equal to, less than, or greater than. So here friends, correct answer is option A, that is equal to. Next is the ultimate tensile stress for mild steel is dash the ultimate compressive stress. Here friends, options are equal to, less than, or more than. So here friends, correct answer is option C, that is more than. Next is the maximum stress produced in a bar of tapering section is at smaller end, larger end, middle end, or anywhere. So here friends, correct answer is option A, that is a smaller end. The maximum stress produced in a bar of tapering section is at a smaller end. Okay. Next is the modular ratio of the two materials is the ratio of here friends, these are the options, and here correct answer is option C, that is their modulus of elasticities. Modular ratio of two materials is the ratio of their modulus of elasticity. Okay. Next is the shear modulus of most materials with respect to the modulus of elasticity is, here options are equal to half, less than half, more than half, none of these. Here friends, correct answer for this question is option B, that is less than half. Okay. Next is question 33. A rod is enclosed centrally in a tube and the assembly is tightened by rigid washers. If the assembly is subjected to a compressive load, then here friends, these are the options, and here correct answer is option C, that is both rod and tube are under compression. Now friends, next is question number 34. A bolt is made to pass through a tube and both of them are rigidly fitted with the help of washers and nuts. If the nut is tightened, then here friends, these are the options, and here correct answer is option D, that is bolt is under tension and tube is under compression. Now friends, next is when a bar is subjected to a change of temperature and its deformation is prevented, the stress induced in the bar is, here friends, these are the options, and correct option is option D, that is thermal stress. Okay. Next is a steel bar of 5 mm is heated from 15 degrees Celsius to 40 degrees Celsius and it is free to expand. The bar will induce here options are no stress, shear stress, tensile stress, compressive stress. So here friends, correct answer is option A, that is no stress. Next is when a bar is cooled to -5 degrees Celsius, it will develop no stress, shear stress, tensile stress, compressive stress. So here friends, correct answer is option C, that is tensile stress. Next is a bar of copper and steel form a composite system which is heated to a temperature of 40 degrees Celsius. The stress induced in the copper bar will be, here friends, options are tensile, compressive, shear, or zero. So here friends, correct answer is option B, that is compressive. Now next is the thermal stress in a bar is dash proportional to the change in temperature directly or indirectly. So here friends, correct answer is option A, that is directly. Thermal stress in the bar is directly proportional to the change in temperature. Next is question 40. The thermal stress dash upon the cross-sectional area of the bar depends or does not depend. So here friends, correct answer is option B, that is does not depend. Next is if there is a fall in the temperature of a composite body, then a member having greater coefficient of linear expansion will be subjected to compressive stress. Is it true or false? So here friends, correct answer is option B, that is it is false. Next is question 42. The thermal or temperature stress is a function of, here friends, these are the options, and here correct answer is option D, that is all of these. So here friends, the thermal or temperature stress is a function of increase in temperature, modulus of elasticity, and coefficient of linear expansion. Next is when a circular bar tapering uniformly from diameter d1 at one end to diameter d2 at the other end is subjected to an increase in temperature T, then the thermal stress induced is, here friends these are the options. Here alpha is the coefficient of linear expansion and E is the modulus of elasticity for the bar material. So here friends, correct answer is option A, that is alpha TE d1 upon d2. Next is question 44. Which of the following statement is correct? Here friends, these are the options and here correct answer is option D, that is stress is directly proportional to strain within elastic limit. The deformation of the bar per unit length in the direction of the force is known as, here friends these are the options and here correct answer is option A, that is linear strain. Next is every direct stress is always accompanied by a strain in its own direction and an opposite kind of strain in every direction at right angles to it. Such a strain is known as, here friends these are the options and here correct answer is option B, that is lateral strain. Next is the ratio of the lateral strain to the linear strain is called, here friends these are the options and here correct answer is option D, that is Poisson's ratio. Poisson's ratio is the ratio of linear strain to the volumetric strain. Is it true or false? So here it is false friends. Now next is a steel bar of 2 meter long, 20 mm wide and 10 mm thick is subjected to a pull of 2 kN. If the same bar is subjected to a push of 2 kN, the Poisson's ratio of the bar in tension will be dash the Poisson's ratio for the bar in compression. Here options are equal to, less than or greater than. So here friends, correct answer is option A, that is equal to. The Poisson's ratio for steel varies from, here friends options are 0.23 to 0.27, 0.25 to 0.33, 0.31 to 0.34 and 0.32 to 0.42. So here friends, correct answer for this question is option A, that is 0.23 to 0.27. So friends, in this video we have completed our part 1 of mechanical engineering competitive exams theoretical questions and answer series on strength of materials. Thank you friends for watching this video. Like, share and comment for this video and subscribe my channel. Thank you.